Good day, everyone. My name is Byron James Angeles from BSCE 4C, and here to discuss about the bolted connection. So before we go to the sample problems, dapat alamin muna natin kung ano nga ba yung bolted connection. So a quick introduction. So connections are a structural elements used for joining different members of a structural steel framework. Steel structure is an assemblage of different members such as beams, columns, which are connected to one another, usually at member ends fastener so that it shows a single composite unit. So ano nga ba yung bolted connection? So it is a connection between structural members made with plates and bolts. From the word bolted connection, gumagamit siya ng bolts as opposed to riveted or welded construction. A bolt is a metal pin with a head formed at one end and the shank threaded and the other end so the nut can be received. Generally, the bolts are used to connect the pieces of metals by inserting them through the holes in the metals at the threaded end. Nuts should be tightened. So from the word bolted connection, ito nga ang ginagamit natin sa mga connections na ginagamit ay yung bolts. So additional information about bolted connection. So on the construction of bolted connection, few persons are required and does not require heating and being safe to the danger of tossing of bolt. Replacement of defective bolts are also done easily than in welded or riveted connection. So overloading may cause a bolted joint to fail prematurely. So ano-ano ba yung mga type of bolts sa ating connecting members? So first is the unfinished bolts, sometimes called ordinary or common bolts. They are classified by the ASTM as 1302 bolts. So next is the high strength bolts. They are made from medium carbon heat treated steel and from alloy steel and have tensile strength greater than those of ordinary bolts. They are designed as A325 and A490 bolts. So ito yung isang example ng bolt, which is ito yung thread, so ito yung nut, ito yung shank, ito yung head, which is yung thread and yung nut, ito yung naglalak para maging matibay or connected yung ating connection or yung ating steel plate. So, ano naman yung mga types of bolted connection? So, first is the slip critical or friction type connection. Bolted connections where high slip resistant is desired. Doon naman sa bearing type connection, the bolting connections where high slip resistant hindi naman siya necessary. So, what are the sizes and type of holes for bolts? So, first is the oversized holes. They are used in all plies of connection as long as the applied load does not exceed the allowable slip resistance. Next is the short slotted holes. They are used regardless of the direction of the applied load if the permissible slip resistance is larger than the applied forces. So next is the long slotted holes. They are used in only one of the connected parts of friction type or bearing type connection. So ito yung example ng isang bolted connection. As you can see, meron ditong clearance hole. Usually, yung clearance hole na yan, nag-a-add tayo ng 2 mm bolt. Bakit? Kasi, kung i-assume natin na perfectly fit siya, yung thread kakasya dun sa may hole, pero so ang mangyayari buong bolt, i-hammer down pa natin yung bolt, which is magkakaroon ng damage doon sa may pinaka-bolt. So paano naman kapag yung hole mismo para sa bolt kasyang-kasya para sa shank. So imagine nyo na lang na gamitin natin eh hindi siya hindi siya masyadong magro-rotate or hindi siya tatama doon sa may mismong thread din doon sa sa plate. So kaya meron tayong different methods of making hole. First is the thermal or gas. So ang disadvantage nito ay inaccurate. The next one is drilling. Ang disadvantage naman nito, ito ay expensive. So yung sub-punching and reaming, so katulad nung drilling, expensive din siya. And yung pinaka-ideal na ginagamit sa paggawa ng holes ay yung punching. So dito, it requires allowance for imperfections and alignment. So next is can be applied only if hole diameter is greater than thickness of plate. So we have different types of bolted connection. So first is the lap joint, butt joint, double plane connection, bolts in multiple shear, triple riveted butt joint, and quadruple riveted butt joint. So meron din tayong different failures of bolted joint. First is the shear failure of bolt, tensile failure of plate, bearing failure of plate, shear failure of plate behind bolt, and double shear failure of butt joint. So now we will proceed on the sample problem. A bolted bearing type connection shown in the figure consists of 16 mm by 150 mm steel plate with diameter of 22 mm A325 bolts and A572 grade 50 plate material with standard holes of Fy is equals to 345.6 megapascal. Minimum tensile strength Fu is equals to 449.3 megapascal. Allowable shearing stress FB is equals to 201 megapascal. For bolt threads exclude from sharp plane, diameter of hole diameter. So find the following. Determine the tensile capacity of the bearing type connection if the bolt threads are excluded from the shear plane. Determine the tensile capacity of the bearing type connection if the bolt thread are included in the shear plane. Allowable shear stress Fu is equals to 145 megapascal. And number 3, compute the theoretical length L if the bolt threads are excluded from shear plane. So for the solution, for the tensile capacity if bolt threads are excluded from shear plane, so unang-una, hahanapin natin yung net area. So from the given na 16 by 150, so ang net area natin ay ito, 150 minus 2. Kasi kung mapapansin natin, kapag hinarap natin siya, tulad ng bolt, which is alam natin na yung part na to is a critical part or dito siya madalas mag-fail. So meron tayong dalawang bolts. And bakit 25? So 'di ba ang ating bolt diameter sinabi na yung hole down natin ay 3 mm bigger sa ating bolt size. So 25. So 22 plus 3 multiply by the thickness 16. So meron tayong makukuhang net area na 1,600 mm square. And yung ating end area ay equal lang siya sa ating net area which is 1,600 mm squared. So kukunin naman natin next is yung area gross. So to solve the area from the given na 60 by 150 na plate, so makukuha natin is 2,400 mm squared. So to solve the tension, meron tayong formula na 0.6 Fy Ag. So direct substitution lang. So T is equals to 0.6 multiplied by 345.6 multiply by 2,400, which is yung area gross, meron tayong makukuha na 497,664. So, for comparison natin kung alin nga ba yung tension, kung alin talaga yung force na gagamitin natin. So, meron pa tayong isang formula na yung T is equals to 0.5 FU multiply by AE. So, equals 0.5. Direct substitution lang din. Multiply by 400. Multiply by 1,600. Meron tayong makukuhang 359,440 Newton. So, para i-check, and meron pa tayong isang way para ma-determine yung force. So, isa-solve naman natin siya through the capacity of bolt in single shear. So, R is equals to AB multiplied by FB. So, yung R natin is equals to pi over 4 multiply sa 22 squared multiply by 207. So, may makukuha tayo na R 8687 Newton. So, i-multiply natin siya sa 4 kasi may makukuha tayo na 314,748 Newton. So, to determine the bearing capacity of bolt, meron tayong formula na R is equals to FP AP. Or R is equals to 1.2 multiply by FU multiply by D multiply by T. So, direct substitution. So, yung R is equals to 1.2 multiply by 4,422 multiply by 16. So, may makukuha tayo ng 189,784 Newton. So, i-multiply lang ulit natin siya sa 4. So, makakuha tayo na tension na 7,137 Newton. So, kung makikita natin, from dito sa tatlo na nakuha natin na 497,664, 359,440, 314,748. So, ang gagamitin natin dito ay yung may pinakamababang load or force. So, ang gagamitin natin ito 48 Newton. So, kung mapapasok, makikita natin, pasok siya sa bearing capacity ng bolt. So, ang 14,748 Newton. So, next is to solve the tensile capacity of both threads are included in shear plane. So, kung mapapansin nyo dito, halos katulad lang din siya nung number 1 without the shear plane. So, dito kasi, may binigay sa ating given na ang ating FU na daw ay magiging 145 MPa. So, kung makikita natin dito, isa-substitute lang siya. Yun lang ang gagamitin natin. So, yun lang ang maiiba. So, kung mapapansin nyo, the same lang din yung method and yung nakuha natin. So, pagdating lang dito sa capacity of bolt in single shear, pinalitan lang natin yung FU ng 145. So, makakuha 20,476 Newton. So, katulad lang din sa pag-solve. So, since mas mababa yung capacity ng bolt in single shear, so yun yung gagamitin natin and siya yung magiging ating safe capacity. So, makakonsider natin siya na safe capacity. So, next is to solve the minimum formula na L is equals to 2 edge of length plus 75. So, yung edge of length is equals to 2P over FU over T. So, direct substitution lang din. Yung yung safe capacity kanina sa number 1 na ito yung safe capacity natin sa excluded from shear plane. So, di-divide lang natin siya sa 4 dahil 4 yung ating bolts. So, ayan, may makukuha tayo na value na P na 78,687. So, yung edge nung length natin, direct substitution lang din. So, 2 multiplied by 78,687 over 449.3 multiplied by 16. So, yung edge of length natin is, makukuha natin is 21.89. So, let's say it was 22 millimeter. Pero hindi pa yan yung gagamitin natin. So, ngayon, meron din tayong formula to determine the minimum edge of length. So, it equals to 1.5 multiplied by diameter of the bolt. So, the minimum edge of the length is equals to 1.5 multiplied by 22. So, makukuha natin na yung minimum daw ng edge of length is 33 mm. So, kung mapapansin natin, 22 ito. So, pero ang minimum natin is 33. So, ang gagamitin natin dito sa formula na to, na edge of length, is yung 33 mm. So, L is equals to 2 multiplied by 33 plus 75. So, ang value ng L natin or yung length natin is 141 mm. And that's all. Thank you.